So on increasing and decreasing functions in the first derivative test, we'll probably spend a couple days on this section, okay, because this is kind of one of those important sections. It's not overly difficult, but it's just one of those things that you need to get down. And so if you remember back to pre-calculus, we talked about what increasing and decreasing functions were. Remember, decreasing meant the graph went down. Okay, so you can see that in the diagram here. Increasing meant the graph went up. So basically, increasing means that your values of f of x are gradually getting larger. And that's what this statement means when it gives you the definition of increasing. And then decreasing functions means the values of f of x are gradually getting smaller. Okay? Notice you also have an option that the function can be constant. So now what we're going to do, instead of just looking at a graph and identifying where it's increasing and decreasing, we're actually going to tie this to the derivative. Okay, tie this to the first derivative, because believe it or not, if a function is decreasing, and you're going to notice this in that handout I gave you, if a function is decreasing, the first derivative is less than 0. So the first derivative is actually negative. Okay? And if a function is increasing, the first derivative is positive. And then last but not least, a function is constant if the first derivative equals 0. So those are things we're going to look at today, and we're going to tie it to the derivative. And so we've got some tests here. And this is kind of what I just got done talking about. It says let f be a function that is continuous on the closed interval. So once again, we have to have that continuity into play. And it's got to be differentiable on the open interval. So once again, okay, you got to be able to find the derivative. If the first derivative is greater than 0. So in other words, whenever we hear first derivative greater than 0, we automatically know that means positive. Okay, so if the first derivative is positive, the graph is increasing. Pretty straightforward. If the first derivative is less than 0, which means it's negative, the graph is decreasing. And if the first derivative equals 0, then f is constant. Okay? So here are the guidelines we're going to go through. So these are the steps we're going to go through. It's not difficult. It doesn't take a lot of time. Okay? But our first thing is to go ahead and, step 1, locate the critical numbers. So the critical numbers occur where what?
C equals 0.
The critical numbers occur where the first derivative equals 0, or where it is undefined.
Yeah.
Okay, so that you got to file that away. First derivative equals 0, or where it's undefined. That is where you find your critical numbers. After you've done that, what we're going to do is we're going to do these test values, and that's not going to probably make a whole lot of sense now, but we're going to make this nifty little table, and it's pretty easy. And then we're going to determine the sign of the first derivative in each of those intervals. Okay? We're going to use theorem 3.5, which is right up here, to determine where it's increasing or decreasing. And then we're going to talk about how you can find if it's a max or a min. So we're going to locate extrema as well. Okay. So let's go ahead and look at this. It says find the open intervals on which f of x is increasing or decreasing and locate any extrema. Now remember, extrema, maxes, and mins. So the first step was to do what? Locate the critical numbers. So to find the critical numbers, I need to set the first derivative equal to 0. So better yet, let's just find the first derivative first. Mm-hmm. 3x squared minus 3x. So now what I'm going to do is I'm going to set it equal to 0 to find any critical numbers. Now here I'm not going to have to worry about anything that's undefined, because you'll be able to find all of these. So if I factor out a 3x, I get x minus 1. So where are my critical numbers going to be located?
0 and 1.
Okay, so x equals 0 and 1. These are my critical numbers. Now what we're going to do based on these critical numbers is I'm going to create some intervals. So you will always start with negative infinity. Why? Because that's the leftmost point of the graph. Okay, that is where you're always going to start these tables. And I'm going to go negative infinity, and I'm going to move across the graph till I hit the leftmost critical number. 0. Okay. So that's my first interval. Now my next interval is going to pick up at 0, and it's either going to go to infinity or it's going to go to the next critical number. So in this case, 1. And actually, you know what, I'm going to go ahead and rewrite 2 because that looks like it's awful close to 0. So 0 to 1. And then my next interval will pick up at this critical number 1, and it's going to go to positive infinity. Now this is a little key. If you have one critical number, you're going to have 2 intervals. 2 critical numbers, 3 intervals. 3 critical numbers, you'll have 4 intervals. So you're always going to have one more interval than what you have critical number. So now what I'm going to do is I'm just going to go ahead and draw a little table like that. Now my next task is going to be to pick a value in each of those intervals. The thing you need to do is pick a smaller value. Okay, so negative infinity to 0, I would probably pick negative 1. Okay, negative 2, negative 5. It's usually good to pick the smaller value so if you can. From 0 to 1, you don't have a choice. You're going to have to pick a fraction or a decimal. We can actually pick 0.5. We could pick a fraction too. It doesn't matter. Okay. Doesn't matter. Okay, and then from 1 to infinity, I could pick the number 2. Okay, so now what you're going to do with each of those numbers is you're going to go and plug those into the derivative right up here. Now I would recommend plugging them in to the factored form, because this is what we're going to think about. Now you don't know, whoa, before you get out your calculator and start doing all this, you can do a lot of these in your head, because remember, all we need to know is if it's positive or negative. We don't need to know the specific number. So if I plug negative 1 in here for 3x, okay, so if I plug negative 1 in here for 3x, I get a negative, right? If I plug negative 1 in here, what type of number do you get? Negative. What is a negative times a negative? There you go. That's all you need to do. So let's plug 0.5 in. Okay, if I plug 0.5 in here for 3x, I get a positive, right? If I plug 0.5 in here, so I have 0.5 minus 1, I get a negative. What is a positive times a negative? Negative. Now, will they always alternate? The answer is no, so you can't just automatically assume that they're going to alternate. So let's plug in 2. Plug in 2 for 3x, what do you get? Positive. Plug in 2 here, what do you get? Positive. Positive is a positive. So now what we can conclude is that the graph is increasing here, the graph is decreasing here, and the graph is increasing here. Yeah. Yep. So now I need to write that. So increasing, this is what you would do. The graph is increasing negative infinity to 0 and 1 to infinity. The graph is decreasing from 0 to 1. Now we're not done, because we need to go ahead and locate extrema. Now extrema are your maxes and mins, and this is a pretty easy thing to do if you can visualize. When a graph is increasing, what does that mean the graph does? It goes up, right? So I'm just going to put a little note here, it goes up. So that's what the graph's going to do at that interval. Okay, when the graph decreases, what does that mean it does? It goes down, so the graph is going to do like that. So do you see what I've kind of visually created? So really, what point will be located here? A max or a min? A maximum. So I know that I'm going to have a maximum value at 0, and I'm going to fill this in a little bit. I'm just going to continue with that thought about the graphing and finding the other extrema. So let's think about here from 0 to 1. Decreasing means the graph goes down, right? What happens from 1 to infinity? Goes up. So really, what visually have I created? A minimum. So that minimum will occur at 1 comma something. So now I need to figure out the point on the graph that it occurs. So where am I going to plug that in? I'm going to plug it into the original equation. You do not plug it into the derivative, because you want to find where does that specific point occur. So you're going to plug 0 into this equation right here. So the max will be at 0, 0. Now if I plug 1 in, I get 1 minus 3/2, which is negative 1 here. And there's your extrema. Okay? So that is the whole problem in a nutshell. We have located where it's increasing and decreasing. We've located the max and min. And we've all done this without looking at the graph. So see, like last year, what you did is you looked at the graph and you visually said, oh, here it is, here it is, here it is. This is actually how you do it algebraically. Now, we will have some application problems as to this. Okay? And that will be coming in the future. It's actually optimization. Okay. So let's look at this one. Yep. First derivative equals? Okay. What's my next step? Yep. Set it equal to 0, because essentially, what do I have to find? Where it equals 0. So, where do you get your critical number to be? So go ahead and do your intervals for me. Set your intervals up. By the way, how many intervals are you going to have? 2.
2.
Okay, so what did you do for your intervals? Negative infinity to 2. 2 to infinity. What values did you pick?
1 and 3.
Okay, I would have actually picked 0. Okay, but you can pick 1 and 3. The reason why 0 is always nice is because whenever you plug 0 in, it's 0, right? So if you plug 0 in up here, you're going to get a negative. What'd you get here? Positive. So you can conclude that the graph decreases where? The graph decreases from negative infinity to 2. Oops, I shouldn't put 2, comma 2. And it increases from 2 to infinity. What type of extremity do you have? Minimum. Where? 2, comma. And I gotta find where that minimum occurs. So I'm gonna plug 2 in. Where'd you find it at? Negative 44. Questions? That's all we're gonna do today. Okay? We haven't covered the entire section, so there'll be some problems you won't be able to do. But let's go ahead and start by looking at the problems you do have to do at the start. Now, real quick, the last thing we're going to do is, this is just kind of one of those definition things. A function is strictly monotonic on an interval if it is either increasing on the entire interval or decreasing on the entire interval. And you're probably wondering, how could that occur? Yeah, so basically, a monotonic would be like a straight line. You could do a straight line. That would be one. Okay, another thing is you could have a graph like that. That would be entirely decreasing. So those are 2 examples. Another one would be like that. That one actually would be like an x minus 1 cubed.
Wait, that's not a constant?
No, that's not a constant. If you actually look at the graph, it is actually increasing the entire time. It looks like it kind of levels out, but that's one of those things that you just kind of need to get used to, what the graph would look like. And so your assignment then is on pages 186 and 187. So let's go ahead and see what those look like so that we make sure that we're starting off on the right note. So on page 186 and 187, we're looking specifically at number 3. 3 through 10. Now, number 3 through 10, they ask you to just identify the intervals on which the function is increasing or decreasing. So that's a review from pre-calc. You're looking at the graph, you're telling me where is it increasing, where is it decreasing. No, you're not identifying min and maxes. Okay, now you're probably wondering, what do you do about 9 and 10? On 9 and 10, you need to graph those using your graphing calculator, since the graph isn't given to you. 17 through 29 odds. Those are exactly like the 2 we did in class. Okay, so those are just like the 2 examples we did in class. You should be able to handle those. 39 and 42. Same thing. Okay. Those I just threw some trig ones in there at you. And then last but not least, 55 through 64, we have not covered, and we will continue with that tomorrow. So 55 through 64 are the ones that we will cover tomorrow.